Now let us see about dynamic programming. Dynamic programming is an approach where the problem is divided into sub-problems. These sub-problems are called as stages. Solving these sub-problems will result in the final solution. So there are three types of dynamic programming. Now first one is dynamic programming under certainty. Second, dynamic programming for continuous variable. Third, dynamic programming for LPP. Now let us see about dynamic programming for continuous variable. In this, the problem is divided into stages, state, and objective function. Stages are number of variables. State is available resources or the constraint. Now let us solve one problem using for a continuous variable. But the objective function is z is equal to a continuous variable is equal to t. Then y1, y2, y3 is be greater than equal to 0. Now first of all we have to write this number of states and the objective function. The stages are 3. Since we have 3 variables, y1, y2 and y3. Then state, we have only one constraint, so we can write as 1. Then the objective function, state z minimum. We have to write the stages right now. Starting from S3, S3 is a stage where y1, y2 as well as y3 is present. So y1 plus y2 plus y3 is equal to. Then for stage 2, in stage 2 y1 and y2 is present. So we have to obtain stage 2 from stage 3. So stage 3, if we minus y3, it will result in y1 plus y2. Similarly, for S1, S1 is obtained by subtracting S2 minus y2, where it is y1. We have to find functions for all the stage. First, let us start from stage 3. So F3 is a function name for S3. Since the minimization problem, minimum of y3 we have to obtain from the objective function. So y3 the whole square plus we have to write y2 plus y1. So we can put it in another function that such as f2 of s2. Then again for s2, similarly for minimum y2 square. Here we have to specify y2 square, so we need y1. So similar as f1, s1. Similarly s1, so minimum of y1, right? So a minimum of y1 is we are writing on y1 square. So indirectly we can write as y1 square. We already solved y1. y1 is equal to s2 minus y2. So s2 minus y2 the whole square. Since we know the value of f1 is 1, we can substitute in the f2. So the equation will be f2 s2 is equal to minimum of y2 square. We know the function value is s2 minus y2 whole square. The next step is we have to find the differentiation equation of the previous one, f2 s2, sorry. So differentiation of f2 will result in with respect to, since we are doing with s2, y2 will be the function. So with respect to y2, so our dou of s2 by y2 will become 0. So then we have to differentiate this equation. So it is differentiation of y2 square, it is 2y square into 1 plus 2 into s2 minus y2 into minus 1 is equal to 0. Then 2y square minus 2s square plus 2y is equal to 0. It is 4y square is equal, y2 is equal to 2s2, y2 is equal to 1 by 2 s2. Since we have calculated the y2 value, we are going to substitute in place of y2. This method is called as the Bellman inequality method. So f2 equation is (1 by 2) s2 the whole square plus s2 minus 1 by 2 s2 the whole square. Solving this equation, 1 by 4 s2 square plus 1 by 4 s2 square, that is 2 s2 square by 4, this is again 1 by 2 s2 square. So we have calculated the f2 value is 1 by 2 s2 square. Similarly, we have to calculate the f3 function, f3 s3. The function is minimum of y3 the whole square plus 1 by 2 s square by 2. We have already calculated the value of s2, so substitute the value of s2 in the place of 1 by 2 s3 minus now perform differentiation of, again a differentiation of f3 s3 with respect to, since s3 it's y3 respect to y3. So again dou f of s3 by y3 is 0. Similarly perform function 2y3 plus s3 minus y3 minus 1. So 2y3 minus s3 minus y3, 2y3 minus s3 plus 3, this 3y3 minus s3, y3 is equal to 1 by 3 is 3. We have calculated the y3 value, so we have to substitute in f3 function in the place of y3. So the equation is 1 by 3 s3 the whole square plus half into s3 minus 1 by 3 s3 whole square. So solving this equation, 1 by s3 the whole square plus 2 by 9 s3 the whole square. So f3 s3 value will be 1 by 3 s3 the whole square. We have calculated the value for, we already know f1 s1 it is y1 square. For f2 s2 it is 1 by 2 s2 square. For f3 s3 it is 1 by 3 s3 square, and similarly for y2 it is 1 by 2 s2, and y3 it is 1 by 3 s3. We have to calculate the value for y1, y2 and y3. So since we know s is equal to s3 is equal to y1 plus y2 plus y3 is equal to 10. So substitute in the place of y3. y3 it is equal to 1 by 3 s3. So s3 it is 10. So substitute the value to 10 by 3. So y3 we have calculated. Similarly for y2 it is 1 by 2 s2. So we know the value of 1 by 2 s2 it is s3 minus y3. So 1 by 2 s3 value is 10 minus 10 by 3. Again the value will be 10 by 3. Since we know y1, y2 and y3, we can calculate from the equation, that is y1 plus y2 plus y3 it is equal to 10. So substitute the value for y2 and y3. So y1 is plus 10 by 3 plus 10 by 3 is equal to 10. So y1 is equal to 10 minus 20 by 3. So y1 is equal to 10 by 3. We have obtained the value for y1, y2 and y3. So substitute in the z value, that is y1 square, that is objective function, y3 square. So it is 10 by 3 the whole square plus 10 by 3 the whole square plus 10 by 3 the whole square. It is 100 by 9. So z value is 100 by 9. Now let us, you can solve these problems using the above techniques. The solution for this problem will be given in the below link.